Hi everyone, my name is Puriya Tawakkoli, instructor of Robo 240, Mechanics and Materials. Today we will perform the experiment of strength of shear connections. The objective of experiments are to understand the difference between single shear and double shear connections, experimentally determine the strength of both single shear and double shear connections, experimentally determine the ultimate shear strength of a material, and compare the ultimate shear strength of a number of materials. This structure is called single shear connection. When the plates are loaded, shear stress is developed in the pin, and since only one surface resists against the loading, this connection is called single shear connection. This connection is called double shear connection. When plates are loaded, shear stress is generated in the pin, and as you see, two surfaces resist against the loading. That's why this connection is called double shear connection. This figure schematically shows single shear connections. Plates are connected by one pin, and as you see, only one surface resists against the loading. That's why the connection is called single shear connection. Pin is circular. That's why its cross section is calculated by pi over 4 diameter squared. Today we will test single shear connections for one pin, two pins, and three pins, all made of aluminum. This figure schematically shows double shear connection. Plates are connected by one pin, and as you see, two surfaces resist against the loading. That's why this connection is called double shear connection. And total shearing area is calculated by 2 multiplied by pi over 4 diameter squared. For double shear connection, we will test it with one pin made of aluminum, again one pin made of copper, and at the end with one pin made of brass. We will use SATEC model T5000 for shear test. As you see, I have already mounted single shear connection plates. Single shear connection plates, they are connected by one pin made of aluminum with diameter of 0.188 inch. When I run the machine, the lower crosshead will be fixed and the upper crosshead will move upward, and it would produce shear stress in the cross section of the pin. The load will increase until the specimen fractures, and at the end we will measure PK, peak load, in pound. As you see, single shear connection is already mounted. The plates are connected by one pin made of aluminum. The diameter is 0.188 inch. The lower crosshead is fixed, and the upper crosshead will move upward, and it will apply shear stress on the pin cross section. Now you can stop it. Now I'm raising test spin very slightly. L2 demonstrates the current load applied, PK demonstrates the peak load, and PS demonstrates the deformation. Look, specimen has fractured through one surface. As you see, double shear connection are mounted to the crossheads. The plates are connected by one pin made of brass. The diameter is 0.188 inch. The lower crosshead will be fixed and the upper crosshead will move upward, and it would produce shear stress on the pin cross section.